All right, today real quick, we are going to go over the notes for the next transformation that we're going to talk about in this unit, and that is translations. A translation is any transformation where all the points of a figure are moved the same distance in the same direction. So if you look here, we got some examples of translations. They're just like a slide to the left or right or up or down. So we've got this race car, it slides to the left. We've got the rose that it's slid over. All right. Now the picture of the dog, that dog has been rotated around a point, and so therefore it is not a translation. In the fish, it is blown up and gotten bigger, so that's why it's not a translation, it's a dilation. Okay. So now we're going to determine the translation that has happened and find the coordinates of the prime points. So the first thing we've got to do is figure out which of these images is the pre-image and which is the image after the translation happened. So we have the triangle on the left and lower left corner is JKL. The triangle on the right, triangle J prime, K prime, L prime. So the prime points, those have been translated. The pre-image is JKL, and we're ending at J prime, K prime, L prime. So the first step here is we got to figure out the coordinates of J prime, K prime, and L prime. So the coordinates of J prime, you can see there on the graph, are at 1, 1. The coordinates of K prime are at 5, -1. And the coordinates of L prime are at 1, -2. All right, so that is where we have moved things to. Now we got to figure out the difference in the x and the y. So if you look, we go from an x of -4 to an x of 1. Well, how do we get from -4 to 1? Well, we have to add 5. And the same is true with all the other points. For k, we added 5 to it. From 0 plus 5, we end up at 5. And L, we start at -4 and we end up at 1. -4 plus 5 is 1. So we are adding 5 to all of those x's. And then for the y's, we have -2 and we end up at 1. We start at -4, we end up at -1. We start at -5, we end up at -2. We are adding 3 to each of those. So we are moving in a positive direction 5 units to the right. So if we think about a vector is anything, it is a movement that has both magnitude and direction. So it is moving a magnitude of 5 in the right direction. So that means it's positive 5 because anything to the right on the x-axis is positive. If it was moving to the left, then it would be negative. All right, then we're moving in the y direction, a positive 3. So we would put a 3 there because we're moving up 3. If you think about it, this is like to the right 5 and up 3. So think about it that way. They're both positive. All right, triangle ABC is translated 1 unit right and 4 units up. So we need to first of all draw the image of A prime, B prime, and C prime. So 1 right and 4 up. So A goes 1 to the right and 4 up. So it moves there, and we'll call that A prime. B goes 1 to the right and 4 up. That goes there, and we'll call that B prime. And C goes 1 to the right and 1, 2, 3, 4. So that's C prime. And now we can just connect the dots. So that is our new triangle that has been, it's the same size as it was. There's no rotation or anything like that. It's still oriented the same way. It's not flipped over or anything, so it's not reflected. It's just slid up and to the right. So A prime's new coordinates are at 2, 1. B prime is at 4, 4. And C prime is at 5, 2. So, using vector notation, we can write a general rule that this translation So because we know that we're going 1 to the right is positive, so we're going 1 to the right, so that is 1 as the x movement. And since we're going 4 units up is positive as well, so that is a positive 4. So that would be how we write that in vector notation, that rule. C prime, okay. So now, writing a general rule which describes the translation shown here. So we just got to look. We start at triangle LMN, and we're going to end at triangle L prime, M prime, N prime. Okay? So if we just take any of those points, we just got to try to figure out what happened to move that. So if we go look at N, letter N, point N, to go to N prime, we have to go to the right 1, 2, 3, 4, 5, 6 units. So we're going positive 6, and then we're going up 2. And if you'll notice, all of those points follow that same movement, 6 to the right and up 2. So our rule is the vector of 6, 2. And notice these are not like parentheses that are on the outside for vector. Those are a different way to show that we are in vector notation. So make sure that you use those different kinds of brackets. All right, so quadrilateral ABCD has coordinates A at 0, 2, B at 3, 4, C at 4, 2, and D at 3, 0. So we're going to determine the coordinates of the new vertices A prime, B prime, C prime, and D prime after a translation along the vector of -2, 3. So the vector -2, 3 means we're moving everything left 2 and up 3. So we're going to subtract 2 from every x, and we're going to add 3 to every y. So 0 minus 2 is -2. 3 minus 2 is 1. 4 minus 2 is 2. And 3 minus 2 is 1. Now we'll go back and do the y's. The y's, we're adding 3 to everything. So 2 plus 3 is 5. 4 plus 3 is 7. 2 plus 3 is 5. 0 plus 3 is 3. All right, so suppose a second translation is applied so that quadrilateral A double prime, B double prime, C double prime, D double prime has coordinates at A double prime is -3, -3, B double prime is at 0, -1, C double prime is at 1, -3, and D double prime is at 0, -5. What is the translation vector? All right, so we're trying to figure out what translation happened to go from the points of A prime to A double prime, from B prime to B double prime, so on and so forth. All right, so we can pick any of those. So let's just, let's go with B. Point B, we start at 1, 7. B prime's at 1, 7, and now we're going to 0, -1. So in the x, we go down 1. So we subtract 1. And then in the y, we start at 7, we end up at -1. Well, 7 minus what equals -1? That is -8. So we're subtracting 8 there. So our rule is, our translation vector is -1, -8. All right, so think about the translation that is shown here in this example 4. Now, obviously, this quadrilateral looks like a trapezoid. We're going to go with trapezoid. Called DEFG, has been translated up and to the right to trapezoid D prime, E prime, F prime, G prime. All right, so we got to figure out what movement occurred to move all these pieces up and to the left, and how far did they go? So as far as to the, sorry, not up and to the left, up and to the right. So it goes 1, 2, 3, 4 to the right, and then we're going up 1. So 4, 1 is our translation vector. And that is the same for all of these points. 4 to the right, up 1. Now, if we look at example 5, we start with the triangle on the right, and we're moving to the triangle on the left. We start with triangle DEF, and we're moving to D prime, E prime, F prime. So if we look at point E, we're going to the left 1, 2, 3, 4 spaces. So it's to the left, so that's -4. And then we're not going up or down any. So instead of writing a 0, we kind of just leave it blank. -4, comma, and then we put our, honestly, it looks like a greater than sign to describe that. But that's not what that means. All right, so with that vector notation, we don't write a 0, we just leave that as a blank. All right, now, you may see it written this way as well. So you may see a vector notation like this. If that is what you see, then, of course, we're not going to move left or right any. All we're going to do is move down 5, because that is just a movement in the Y. All right, so I just wanted you to be aware of that. In case you see that, I believe there's one in the homework like that, so make sure you pay attention. If you have any questions, please shoot me an email or a Canvas message, and I'll get back to you as soon as I can. I want you to have a great day.